So essentially, we've cut our power consumption by 1/3 just by changing our incandescent light bulbs to a CFL light bulb. Now, some people in the past have made comments about, for instance, the ambiance that a CFL light bulb emits. But with later generations of CFLs, you can find many different types of hues of color in which can mimic what an incandescent light bulb looks like, since a lot of us are used to more of that yellowish type of warm light. So there are warmer CFLs out there. So just by using CFLs in your home, you can cut your lighting load down to 1/3 of what it currently is. Now, the next generation of light bulbs that are even more efficient than CFLs are LEDs. LED stands for light emitting diode. So in the same scenario, we have 10 light bulbs. An LED light bulb, a very bright LED light bulb, which would be the equivalent of a 60-watt bulb in luminosity, will only draw 4 watts of power. And some are even smaller than that, 3 to 2 watts. So an LED light bulb, if we have one that is drawing 4 watts, and we have 10 of those bulbs, that means 10 lights are using only 40 watts in an hour. So in 4 hours' time, that's only 160 watts of power being used, compared to 3,000 watts for incandescent light bulbs, and then compared to approximately 600 watts used by CFLs. So LED lights, which are more expensive right now because they're still working up in newer technologies, give you a tremendous difference in the amount of power that one uses. On top of that, a CFL light bulb, the average CFL can last about 8,000 hours. What does that mean in true terms? Normal people may have their lights on, let's say, for 5 hours in a day at night. So in 1 month, you've got about 150 hours. And in a year, you've got about 1,500 to 1,800, let's round it up to 2,000 hours in a year of your CFLs. So CFLs theoretically can last about 4 years' time. Now, an LED light bulb lasts 50,000 hours. So one LED light bulb that you purchase, or those 10 LED light bulbs that we used in that example, in the same scenario, with 5 hours a day, in a month, that's 1,800, or we'll round it up to 2,000 hours. 2,000 hours a year. Divide that by 50,000. You've got a light bulb that can last almost 20 years, 25 years. You will never change an LED light bulb unless something, of course, there's a flaw within the design. But once you have an LED light bulb, you are not going to change that light bulb in that particular fixture probably for 20 years. They are cooler, they draw very little electricity, and LED lights, which are more expensive, so the capital outlay is a little bit more, are one of the most efficient uses with a solar system itself. Now, other appliances, just to give people an idea of how many watts other appliances or how many kilowatts an appliance uses in a year. Most refrigerators use about 400 to 500 kilowatts in a year. That translates into about 40 kilowatts a month. A washing machine will use anywhere from 200 to 500 kilowatts a year, kilowatt hours a year. Now your stove, this is something that's very important. A stove uses essentially, an electric stove can use 10 kilowatts an hour. So when you're using the stove for 1 hour, you're using 10 kilowatts. That's a lot of power that's being used just for an electric stove in a day. Let's talk about one of the things that I do myself, water heaters. Water heaters use about 5 kilowatts. And if you keep a water heater on, an electric water heater on all day, that's like having your dryer, your stove, all the lights on, your lawnmower, everything running while you're not at home. So one of the best ways, most effective ways that a person can save on electricity, if you have an electric hot water heater, is to shut the water heater off when you don't need it. Now, sometimes it takes discipline to do this. Most water heaters have a temperature sensor, but what happens is when the temperature of the water goes down, of course it kicks on to keep the temperature up to stable, whatever, 120 degrees if it is set for normal hot water settings. So if you keep that on for, once again, an hour, you are drawing a tremendous amount of power just to heat water. And if you're not using that water, it's still being heated up. So one of the things that I do, and I'm pretty disciplined about this, and also my AC panel is located in a pretty easy spot. When I leave in the morning, I shut the hot water breaker off. I go right to the breaker itself and flip the breaker so there's no power running to that hot water heater. When I come in the house, I just flip the breaker on the hot water heater, and then usually within 10, 15 minutes, the water's going to be fine. And remember that most water tanks are already insulated, so hot water will still be there. It's not going to be dreadfully cold, and it never is. So now when we look at, for instance, on-demand hot water heaters, which are really good, an on-demand hot water heater is essentially a small water heater, an electric water heater that is located to a point source, meaning it is underneath or in the vanity of your bathroom, or it's underneath your kitchen sink. And when the water turns on, that's when the hot water, that's when the heating element turns on. When it's off, there's no electricity going there. So on-demand hot water heaters, which are used overseas in many places, very rarely do you see the kind of hot water systems that are being used here in America overseas. Most are on-demand hot water heaters, especially in tropical environments. So they use essentially almost 1/4 the amount of power that your standard electric hot water heater would utilize. So as we now get involved in solar in our nation would be best on the residential homes. Now, one of the big cons of solar right now is, unfortunately, the pricing of solar. An average solar cell right now, or a 6-kilowatt system, let's look at that. A 6-kilowatt system is a system that can pretty much provide all of the power of one's home in a day. Now, what does a 6-kilowatt system mean, and how much power can it produce in a day? If you take the average sunlight, let's say look in the United States of America, and if we look at the location where we're going to be at in Africa, pretty much not too far north or south of the equator, we should be able to get a solar mean of about 6 hours a day, meaning that we should get 6 hours of good direct sunlight to hit those panels and produce electricity. And if we use that as an average, 6 hours times a 6-kilowatt system gives us 36 kilowatts of power generated in a day.